Welcome to Unit 1, Lecture 1 for Introduction to Logic. So what I'm doing here is I'm just taking the lecture notes that are on the website and be working through them. So you can find exactly what I'm be covering today by clicking on Lecture Notes on the website, then Unit 1 Lecture Notes. And it's just this document. I've zoomed in a little bit to make the font size bigger on the video. But other than that, it's the exact same notes I'm covering that are on the website. So we have a lot to cover today. This will probably be one of the longer lectures. So I'm going to get right into it. We're going to start with basic definitions. So what is this course about? This course is about logic. We can say that logic is either about reasoning or it's about arguments. So logic is either the science of the correctness or incorrectness of reasoning, or to say basically the same thing, we can say logic is the study of the evaluation of arguments. And what do I mean by reasoning? What do I mean by an argument? So reasoning is something that occurs in your head. You have certain thoughts. On the basis of those thoughts, you form other thoughts. That's called reasoning. So I reason from certain thoughts to other thoughts. If I take those thoughts and I put them into words, I express what's called an argument. An argument is part of language. It's made up of words. So an argument is made up of sentences. Those sentences are called statements. So a statement is a sentence, a part of a sentence, that's either true or false. The kind of thought that's either true or false, if you express that in a sentence, you have what's called a statement. So I say Boston is the largest city in Massachusetts. That's one statement. I can also form compound statements, like in this example. And this is a little bit tricky. I'm asking a question here. How many statements are there in this compound sentence? Boston is the largest city in Massachusetts, and Springfield is the second largest. It's actually a trick question. It's kind of like this square over here. How many squares are here? Now the answer might seem to be 4, but it's actually 5 because you have to count the entire big square as well. So I say, how many statements are there in Boston is the largest city in Massachusetts and Springfield is the second largest? The answer is actually 3. Each of the halves is a statement, but the entire thing is also a statement. So statements can be a bit tricky. We put statements together, and one of the things we can do with statements is we can form an argument. I'm going to skip over what a proposition is. A proposition is the idea or notion that a statement expresses, but that's not so important for our purposes. I want to focus on what an argument is. So an argument is a collection of statements. We've got some of them are leading to one of the others. So an argument is a collection of statements or propositions, some of which are intended to provide support or evidence in favor of one of the other statements. So these statements provide support for this other statement. So we can divide the statements in an argument into the premises and the conclusion. The premises of an argument are the statements that in it that are providing support or evidence. If you think of them as thoughts, they're the thoughts you already had. Those thoughts are going to lead to a new thought. The new thought's called the conclusion. So the conclusion of an argument is the statement in it that the premises are trying to provide support for. So let's look at certain examples. So let's look at the things here in red. We're going to try to identify the conclusion in each of these arguments. So the entire paragraph here is an argument. God is defined as the most perfect being. A perfect being must have every trait or property it's better to have than not to have. It's better to exist than not to exist. Therefore, God exists. So this argument, this paragraph here is trying to convince you of something. The thing it's trying to convince you of is called the conclusion. So in this example, the conclusion is the last sentence. Therefore, God exists. The word therefore is an indicator, giving away that's the conclusion. All of the other statements are premises that are being used to provide support for that conclusion. So that's when you have an argument. You've got some statements that provide support or evidence in favor of one of the others. The statements that are providing support are called the premises. The statement that are providing support is called the conclusion. I'm going to get back to this inductive and deductive stuff later. It doesn't have to be the last sentence in the paragraph. So if I say Hillary Clinton must be a communist spy, after all, she supports socialized healthcare, and everyone who supports socialized healthcare is a communist spy. This argument was originally given as a joke, but now it kind of makes me cry. I think people might not take it as a joke. But what's the conclusion here? So in this particular example, the conclusion is actually the first sentence. Hillary Clinton must be a communist spy. That's what they're trying to convince you of. They're trying to say, here's why I think she's a spy. She supports socialized healthcare, and everyone who does so is a spy. Here's why I think she's a spy. What they're trying to convince you of is that she's a spy. That's the conclusion. So here it's actually the first statement. It has rained more than 15 inches per year in Amherst every year for the past 40 years, so you can safely bet it'll rain more than 15 inches in Amherst this year. Here's what happened in the past. That's good reason for thinking here's what's going to happen this year. So they're giving you a reason to think this is what's going to happen this year, so the conclusion is the second statement here, and the first statement is being used as a premise. In this next example, the conclusion is actually in the middle. Professor Chappelle said the ratio of in-state to out-of-state students in the class was exactly 3 to 1. This means there are 112 in-state students in the class because there are 148 students in the class total. Now, if you do the math for this particular example, turns out the math is wrong, but it's still an argument even if the reasoning is bad reasoning. They're trying to convince you of something. If they're trying to convince you of something with the paragraph, that makes it an argument. But what's the conclusion, right? Here's what he said about the ratio. Here's how many students there are. The conclusion is this is how many in-state students there are. So this is the conclusion here in the middle. Google has a feature to search only pages changed in the past month. It stands to reason that Bing allows you to limit searches to pages changed in the past month as well, since the two search engines tend to provide the same features. So again here, the conclusion is in the middle. They're saying, here's what Google does. Google and Bing tend to be similar, so Bing is probably like that too. The conclusion is that this is the way Bing is, because this is the way Google is, and the two tend to be similar. So again, this first statement is a premise, this middle statement is the conclusion, this last statement is another premise. 1 is prime, 3 is prime, 5 is prime, 7 is prime, therefore all integers between 0 and 8 is prime. Again, the therefore is a dead giveaway that this is the conclusion. Jason isn't an NRA member. Almost 90% of NRA members are Republicans, and Jason isn't a Republican. They're trying to convince you that Jason isn't an NRA member. So the first statement here is the conclusion. And these are all examples of arguments. You've got premises and a conclusion. We can divide arguments into two subcategories, inductive and deductive. So sometimes people are taught this a different way. So there's an older definition of these words, inductive and deductive, where it means, deductive means reasoning from the general to the specific, and inductive means reasoning from the specific to the general. That's not the way we're going to use those words. That's an old, outdated way of using those words. We're going to use them a different way. It has to do with the strength of the intended evidence. What kind of argument are they trying to give? Are they trying to give the kind of argument that's so strong that it's impossible that the premises could be true and the conclusion to be false? If the conclusion follows necessarily from the premises. If they are, that's called a deductive argument. They're trying to give the kind of argument where it's just improbable that the premises could be true and the conclusion to be false, or it's unlikely that the conclusion could be false and the premises are true. That's called an inductive argument. It has to do with how strong they take the link between the premises and the conclusion to be. Another way of putting it is when you make an inductive argument, you sometimes think that the truth of the conclusion is somehow contained in the truth of the premises. There's nothing above and beyond what's involved in the premises being true and for the conclusion to be true. Okay, so let's go back to these examples. So the person who thinks it's just true by definition that God would have to exist because God has every perfect trait. They think there's nothing else about these definitions that makes it true that God exists. That's a deductive argument, right? Because it's not probabilistic. It's not probably God exists. It's necessarily God exists. If this is the definition, this is what follows from the definition. So basically definitions or arguments that rely on definitions tend to be deductive. Arguments that just rely on logical form, like this one, the Hillary Clinton one, are also deductive. Everyone who supports socialized healthcare is a communist spy, and she supports socialized healthcare. If it's really true that everyone who supports socialized healthcare is a communist spy, and she's one of them, there's no gap between that and the truth of the conclusion. So this is a deductive argument. This next one, though, is inductive. We're saying here's what happened in the past, but here's what's probably going to happen in the future. That's just probably. It's not contained in the truth of the premises just because it happened in the past that it's going to happen in the future. You're going above and beyond the premises to get to the conclusion. That's an inductive argument. This next one's kind of a trick question. Usually if an argument just relies on math, it would be a deductive argument. But this one, Professor Chappelle said that the ratio of in-state to out-of-state students in the class is 3 to 1. there are 148 students in the class total, therefore there are 112 in-state students. You're not just relying on math here, you're also relying on testimony. Professor Chappelle said that the ratio was this. Because we're relying on testimony, it does go beyond the truth of the premises. It could be that he said it and it's not true. So because of the words said that here, this is inductive. Right? Google and Bing tend to have the same features, and Google has this feature, therefore Bing does too. This is inductive because it's not that it's contained in the truth of they tend to have the same features. It doesn't say they have all the same features, it just says they tend to have the same features. So probably it has this feature as well. So this is inductive. These next two examples I put on here to show the difference between the old definitions and the new definitions. So 1 is prime, 3 is prime, 5 is prime, 7 is prime, therefore odd integers between 0 and negative prime. This is deductive. There's no gap between the truth of these premises and the truth of this conclusion. This is a deductive argument. Even though it reasons from the specific to the general, it's still deductive. Whereas this next one is inductive, because we're only saying what 90% of NRA members are Republicans. Jason isn't a Republican. He could be part of that 10%, but he probably isn't. So he probably isn't an NRA member. This is a probabilistic argument. It's a probabilistic argument that's going to be inductive. Now, I want to point out that in this Professor Chappelle one, the math is wrong. So that doesn't make it a different kind of argument, right? So whether an argument's inductive or deductive, it doesn't mean that you actually give an argument that's as strong as you think it is. It's just that you think you're giving that kind of argument. So you could be wrong. It's about what you're intending to do with the argument. If you intend to make an inductive argument, and it actually is the case that the conclusion follows probably from the premises, you give a strong argument, but you could give a weak inductive argument. So this is actually a weak argument, Professor Chappelle's one, because even though it probably is true that he said it, the math is wrong. Because the math is wrong, it isn't probably true that there are 112 in-state students. It's probably that there are 111. I think that's the way the math actually works out. So it has to do with the strength of the argument you're trying to give. Now this class is entirely a class in deductive argument. We're not going to talk about inductive logic after today. Set that to the side. So if you're actually interested in probability theory, take a class in statistics or probability theory in the math, or a lot of the other departments here teaches class in statistics and probability. This is going to be a class in deductive logic. So necessary kind of reasoning. The truth of this conclusion is contained in the truth of the premises. That's the kind of thing we're interested in. Now, if you try to give that kind of argument, you're giving a deductive argument. If you actually succeed in giving the kind of argument where it would be impossible for the premises to be false if the conclusion was, if the conclusion to be false if the premises are true, you're giving what's called a valid argument. A valid argument is when the premises support the conclusion necessarily. An invalid argument is a deductive argument where you try to give an argument like that, but you don't succeed because your reasoning is wrong, or your math is wrong, your definitions are wrong. If you make a mistake in reasoning, your premises don't actually provide your support for your conclusion necessarily, but you're trying to do that. You're giving a deductive argument, but it's invalid. So a valid argument is one where the process of reasoning is actually a good one. The truth of the premises actually support the truth of the conclusion necessarily. And the way you would test for that is imagine the premises are true. So you don't worry about whether they actually are true. You just imagine that they're true, whether they are or not. And then you ask yourself, if I imagine the premises being true, could I still imagine the conclusion being false? And you can still imagine the conclusion being false even though you're imagining the premises being true. It's an invalid argument. But if you can't imagine the conclusion being false when you imagine the premises being true, then you've got a valid argument. And I think this is going to be a lot clearer if we see some examples. So we say all toasters are items made of gold, and all items made of gold are time travel devices. Therefore, all toasters are time travel devices. So the first two statements here are the premises. The last statement here is the conclusion. Now, you're not going to worry about whether those premises are actually true. Now, you know enough about the actual world. You know that toasters aren't made of gold, and that things made of gold don't tend to be time travel devices. You know that, but ignore that. Think about what would happen if these premises were true. So if these premises were true, if it were the case that all toasters are made of gold, and it were the case that everything made of gold are time travel devices, it would have to be the case that the toasters would be time travel devices as well. They're all made of gold. Everything made of gold is a time travel device. So the process of reasoning here is good. This is a valid argument. The premises do provide support for the conclusion. Right? So if the premises do provide support for the conclusion in deductive argument, you've got a valid argument. If the premises were true, the conclusion would have to be true as well. That means that this is still kind of a silly argument. It's not a good argument. There's more than an argument being good than just being valid. This argument is valid, but it's not enough to make it a good argument. A good argument has to have true premises as well. When an argument, all its premises are true, we say it's called a factually correct argument. So a factually correct argument is an argument with all the premises are true. Now, we apply the word factually correct and the word true to different things. I say that the individual premises making up the argument are true. Those are statements. A statement is either true or false. I never say that a statement is factually correct. But when all the statements making up the premises of an argument are true, I say the argument is factually correct. I apply the word factually correct to an argument. I never call a statement factually correct. I never call an argument true or false. But I'll say an argument is factually correct when all its premises are true. We don't talk about factual correctness for the conclusion. It's about whether the premises are true. But if an argument is valid and it has true premises, the truth of the premises would guarantee the truth of the conclusion. So it would have to have a true conclusion as well if it's both valid and factually correct. If an argument is both valid and factually correct, we call it sound. Sound argument is an argument that's both valid and factually correct. So a good argument is a sound argument. You can have every combination of true premises, true conclusion, false premises, false conclusion, except for a valid argument with true premises and a false conclusion. You can have an invalid argument with true premises and true conclusion, false premises, false conclusion, false premises, true conclusion, true premises, false conclusion. If it's invalid, everything's possible. It's a little bit weird. An invalid argument is one where the process of reasoning is no good. If I give you an argument with everything true, but the process of reasoning isn't any good, I can say everything true, but it'd still be a bad argument. If I say 2 plus 2 is 4, gold has atomic number 79, therefore Trump is president, everything I said was true, but the premises don't provide support for the conclusion. It would be possible to imagine those premises being true and the conclusion being false. So it's an invalid argument, but everything I said was true. So everything is possible. So valid arguments, though, you can have false premises and a false conclusion. Like the time travel device, you can have false premises and true conclusion. True premises and true conclusion. The only thing you can't have is a valid argument with true premises and a false conclusion. Sound arguments always have true conclusions. Whether an argument is valid or invalid is determined by its form. So that's really what we're studying throughout this class is the form of arguments. The idea of a form of the argument is best seen by examples. So let's look at these two arguments. All tigers are mammals. No mammals are creatures with scales, therefore no tigers are creatures with scales. Let's look at the second argument here. All spider monkeys are elephants. No elephants are animals, therefore no spider monkeys are animals. If you look at these, they use the same process of reasoning. They both have the form all A or B, no B or C, therefore no A or C. They reason in the same way. They have the same form. Whether a deductive argument is valid or invalid is determined by its form. Both of these arguments are valid. Right? The first one is sound because the premises are actually true. The second one isn't sound because it's not factually correct. The premises are false. But in terms of validity, they're both valid. So validity has to do with the process of reasoning. There's nothing wrong with the process of reasoning in the second example. The process of reasoning is okay. Now, when you start with false premises, you can end up with a false conclusion. So with true premises, you'll end up with a true conclusion, but the process of reasoning is the same. So if you have a good process of reasoning, we call the argument valid. You can also have arguments with the same form where both of them are invalid. So look at these two examples. All Jedis are one with the Force. Yoda is one with the Force, therefore Yoda is a Jedi. All basketballs are round, the earth is round, therefore the earth is a basketball. These two arguments have the same form. All A are F, X is F, therefore X is an A, right? That's the form there, all A or F, X is an F, therefore X is an A. Both of these two arguments, they have that same form, and they're both either valid or invalid. It turns out in this particular form, the form is invalid. Now you can see that it's invalid if you look at the second example, right? Those premises are true, but the conclusion is false. If the premises are true and the conclusion is false, you know it's an invalid argument because it's impossible for a sound argument to have a false conclusion, right? You know the premises are true, so it's factually correct, but the conclusion is false, so it's got to be invalid. Now this first argument here with the Jedis, this example 3 here, that might look like a good argument, because at least in fiction, all Jedis are one with the Force, Yoda is one with the Force, therefore Yoda is a Jedi. So in the truth of Star Wars, everything here is true, but actually it's not a good argument, again, because the process of reasoning isn't any good. It seems like it uses a good process of reasoning, but if you think about that process of reasoning a little harder, you'll realize that this isn't a good process of reasoning. You can have an argument with this form with true premises and a false conclusion. It could have been that all Jedis are one with the Force and Yoda is one with the Force, but Yoda was something else. Yoda was the Sith, who are also one with the Force, right? So you can't imagine these premises being true and this conclusion being false. That makes an invalid argument, right? And one way you can test that is by using something called a counterexample method. So we've covered two things today. Deductive arguments with the same form are either both valid or both invalid. But valid arguments with true premises always have true conclusions. It's impossible to have a valid argument with true premises and a false conclusion. So if you put those 2 points that we've already covered together, that means if you can find an argument that has the same form of an argument you're interested in, that has true premises and a false conclusion. So if you find an argument with the same form as the argument you're looking at with true premises and a false conclusion, that means both arguments are invalid. That's called finding a counterexample, right? So if I didn't know whether this Jedi's example was a good argument, I can just think about arguments like it. If I can find an argument like it with true premises and a false conclusion, then I know both arguments are invalid. So I can find this example, all basketballs are round, the earth is round, therefore the earth is a basketball. Since that has true premises and a false conclusion, since it's invalid, this other one has to be invalid as well, right? So suppose I look at this argument, all Bandersnatches are toves, some Borogoves are toves, therefore some Bandersnatches are Borogoves. You probably don't even know what those words mean. Because you don't know what the words mean, you probably don't know whether the premises are actually true or actually false. That's not going to tell you whether it has a good process of reasoning. When you think about the process of reasoning, you want to think about, can there be an argument with this form? Can I imagine the premises being true and the conclusion being false? Can I have an argument with this form that has true premises and a false conclusion? If I can think of an argument that has this form with true premises and a false conclusion, then I know the argument is invalid. So all fish are aquatic animals. Some mammals are aquatic animals, therefore some fish are mammals. Here we've got true premises and a false conclusion, but it has the same form as this Bandersnatch toves example. If I can find an argument that has the same form with true premises and a false conclusion, then I know both arguments are invalid. Right? If you've got a valid argument, however, it's not going to be possible to find a counterexample. All Bandersnatches are toves, some Borogoves are Bandersnatches, therefore some toves are Borogoves. So this one, if you imagine all Bandersnatches being toves and some Borogoves being Bandersnatches, those Borogoves that are Bandersnatches are going to be toves, so those toves are also going to be Borogoves. So it's going to be true that some toves are Borogoves. It's not possible to imagine premises of this form where the conclusion is false. So true premises are false conclusion. If you imagine the premises being true, you have to imagine the conclusion being true as well. So a valid argument is, again, about the process of reasoning. This has a good process of reasoning. If you have a good process of reasoning, you're not going to be able to find a counterexample. Now, a counterexample method is kind of a difficult procedure because you have to think about all the possible things that an argument of that form could be like, right? If you think of an argument with the same form that has true premises and a true conclusion, that doesn't mean the argument is valid, because you could still find a different argument with true premises and a false conclusion. And if you can't find any at all, then it's going to be valid. You have to think about all the possibilities there. That's called using the counterexample method to test or prove an argument. So I went through this material kind of fast today, but let me just recap the important points. So deductive logic, what you're doing is you're trying to give an argument where the truth of the conclusion is contained in the truth of the premises. If you succeed in giving an argument like that, where the premises really provide support for the conclusion necessarily, you're given a valid argument. That's about the process of reasoning. If the process of reasoning is a good one, we call it a valid argument. To be a good argument, though, you don't just have to have a good process of reasoning. You have to start with true thoughts to begin with. You have to start with true premises. If the premises are true, it's called factually correct. If it's both valid and factually correct, we say that it's a sound deductive argument. That's all I'm going to cover for today. Thank you for listening to Lecture 1. Catch you in the next one.